Okay, so our objective on these problems are to draw the shear force and the bending moment diagrams. And you see I've already got some templates laid out for you. We'll start with the one on the left first. So what are the reactions? We always like to start with our reactions. I'll kind of shortchange those a little bit and tell you that the reaction here on the left side is going to be P acting up. Is that positive shear or negative shear? Positive. And that also the moment will be in this direction and it'll be equal to PL. What kind of bending moment is that? Positive or negative? That's negative bending moment. Okay? What would be the moment at the free end? 0. So I know that my moment diagram should start at negative PL and end at 0. And I know my shear diagram should start at positive P and end at? We'll just have to see when we get there. All right, so let's apply our relationships. The first one is that the change in shear is the area under the load curve. Well, actually, I should have started with what I know. I know that my diagram is going to start off at positive P, right? I found the positive shear. So the change in shear is the area under the load curve. What is the area under the load curve? 0. So that means that I should have no change in shear. That means I better hit positive P on the other side. Our other relationship is that the slope of the shear diagram should be equal to the load. And what's the load? 0, so we should have a 0 slope. So that tells us that our shear diagram is constant, positive P. Now if you're trying to reconcile how this load, positive P, matches with this applied load, imagine that you cut the beam just a little to the left and then look at what positive shear would be there. And if you take a free body diagram just of this little chunk here on the end, what is the shear equal to? P. So it matches. Okay? Now we'll do the same thing for moment. So our relationship is that the change in moment is the area under the shear diagram, and that the slope of our moment diagram is equal to the value of the shear. So what do we know about moment? We know it's going to start at minus PL, right? And it should go to what on this side? 0. That's pretty good. Does that match our integral relationship? Is the change in moment equal to the area of the shear diagram? Well, what is the area under the shear diagram? P times L, and that's positive, right? So if I start at negative PL and I add positive PL, I do in fact get to 0. So that's good. Now the slope of that curve should be equal to the shear. And the shear is constant and positive. So here's a constant positive slope between those 2 points. In fact, if you want to note it, we can say that it has a slope of P. And there is my shear diagram. My moment diagram. So what's the maximum moment in the beam?
0.
Minus PL. What's the maximum shear in the beam?
P.
P. Will you ever see a problem this simple again? No. Let's work this one. This is the equivalent of the concentrated load. This is the concentrated moment applied at the end. So again, I'll short circuit this a bit and tell you that the reaction moment is m naught and that there is no shear in the beam. Right? If you sum forces in the y direction with the shear at the left side, what does it have to be? 0. So what does my shear diagram look like? Nothing. There is no shear. What about my moment diagram? Well, I start with a moment of positive m naught on one side, and I should end with positive m naught on the other side. So that's what my targets are. Let's see if it matches. It says the change in moment between any 2 points is the area under the shear diagram. What's the area under my shear diagram? 0. So that means if I start at positive m naught, I should end at positive m naught. There is no change. The slope of the curve is equal to the shear. What's the shear everywhere? 0. So I have a 0 slope. I retract my previous statement. This is the simplest shear force and bending moment diagram that you can probably draw. And you won't see that on the exam either. So any questions about that one?